Hello and welcome to CEB. Today we will design finite automata for sigma equal to 1 divisible by 2. So first of all, we will understand what is sigma equal to 1. Sigma equal to 1 indicates that this is a unary number system. So this is the unary number system. From where I came to know that this is a unary number system. Unary number system is a system which contains only one digit for creating the entire number system. So if this is the one digit that is used to create the entire number system, so what will be the possible numbers that can be generated by this single digit 1? So let us discuss that thing. So suppose we are having decimal number, and now we will find out the corresponding unary number. So we are having decimal number 1. So by using single digit 1, how I will write down the unary number. So the decimal equivalent of decimal equivalent of number 1 is nothing but the number of occurrences of this digit. So decimal number 1 means 1. So how many times this 1 will be going to appear? This is going to appear only once. So this is the unary equivalent of this decimal number 1. Now we will consider decimal number 2. Decimal number 2 for this unary number system indicate this bit will be repeated twice. That means this will be number 1 and then this will be now number 2. Two occurrences of this digit indicate number 2. What is the decimal equivalent of number 3? That is nothing but the uh, repetition, 3 times repetition of this digit. So this is 1, 1 and 1. So this is number 3. The number 4. Number 4 will be 4 times this digit, that is 111. Now decimal number 5. What will be the equivalent of decimal number 5? Is nothing but 5 times this number. Now what is the equivalent of decimal number 6? Decimal number 6 is 6 times your digit. 7 will be 7 times your digit, that is 1. 8 means 8 times your digit, that is here the number 1. 9 means 9 times your repetition of your bit, that is number 1. Now why we are not having number 10? Because here we have considered decimal number. Decimal number means always it will start from 0 to 9. That's why we are now going to count 10 here. Now, what we are going to do now, we are going to solve the question. What is our question is we have to find whether the unary number is divisible by 10 or not. So what we are going to do now, we are going to find out the mathematical method of solving this question. So the second step is we are going to solve by using the mathematical method. So we will solve by using the maths method. So what is there in maths method is that we have studied in our primary schools, that whenever we have to find the number is divisible by 2 or not, we are going to divide that number by 2 by using this notation. So here we are going to write divisor, and here the number this which we want to divide. So 2, when number 1 is going to be divided by number 2, the remainder will be 1. So this is your remainder 1. When the number 2, for example, the second number is 2. Now we are considering the unary number system. So in unary number system, what we are going to do? We are going to write the unary representation of number 2. So this is the unary representation of number 2, which is nothing but 2 occurrences of your bit, that is 1. So this is now this 2 will be now your dividend. Your dividend is your 2, and then we are going to divide it by 2. So we can write here for our reference, we will write that this is the number 2. So now we are going to divide it. So when we are going to divide it, we will get the remainder as 0. So this is your remainder 0. Now we will consider the next number. We have considered the number. We have considered here number 1, number 2. Now we are going to consider number 3. What is number 3 in unary number system? This is number 3. So what I'm going to write here, triple occurrence of your bit, that is 1. That is your symbol. So 2. When we are going to divide 3. So this is the 3. When we are going to divide by 2, what kind of remainder we are getting? We are getting remainder 1. Now we are having the next number is 4. The 4 number is represented by the 4 occurrence of 1. So this is number 4. Now we are going to divide by 2. What we are going to get? We will get remainder as 0. Now we are having number 5. Number 5 is this one. So when we are going to divide by 2, what kind of thing we are getting? We are getting remainder as 1. Now we are having next number as 6. 1, 2, 3, 4, 5, 6. When we are going to divide by 2, what kind of thing we are getting? We are getting remainder 0. Now when we are having remainder, we are having number 7. Now if we are going to divide by 2, what we are getting? We are getting remainder 1. When we are having number, next number, what is 8. So what we are getting? We are getting remainder 0. Then we are having number, last number, which is 9. Now if we are going to divide by 2, what we are getting? We are getting remainder 1. Okay. Now we will switch to the our thesis method. So what is there in thesis method? So we are going to solve our question by using thesis method. So what is there in thesis method? What we have solved by using mathematical method, the same concept we are going to use. For using that thing, first of all, we are going to determine the number system. The number system we are using is unary number system. Unary number system means we are having only one symbol, single symbol. Okay, single symbol we are using, and that symbol is nothing but here in our case is 1. Okay, so for solving the question by thesis method, what we are going to do? We are going to consider one tape. What kind of tape it is? This is an infinite tape which is open from your right hand side, and it is going to consist of so many cells. This consists of infinite number of cells. And what we are going to do? We are going to write your bits, your symbol here. One symbol at a time will be considered here. Okay. Now in order to solve this question, our question by thesis method, we will consider this tape. Plus this tape is having a pointer which is going to point you where actually you are. What is your current position? And after reading the first bit, the pointer will move to the second bit. After reading the second bit, it will point to the next bit, and so on. Okay. Now this position in which we are ready for reading the data. So this position in which we are not having any input and any output, we can represent this condition, this ready condition, this ready, or we can say the start condition. We can call it a name. We can call it by a name QS. So what is QS? QS represent ready state. We are ready to accept the data. Now what kind of string is represented by QS? String represented. The string represented by QS is nothing. What kind of output generated by our QS? So output generated is nothing. Here we are not have any kind of output because this is ready to go. So now what we are going to do? Now we are going to take, as we have considered the unary number system, we have to decide how many tapes will be there. So as there is a single symbol, so the number of tape, the number of reading tape will be only 1. So based on the symbol, the number of tape will be decided by the number of symbols present in your number system. So here only one symbol is there, so we are going to use only one tape. Okay, now this is the ready position. Okay, now as this cell is your tape is consists of so many cells, we are ready to read the first symbol. So the what will be the first symbol? The first symbol will be based on your number system. The number system here is the unary number system that consists of this bit. That means I'm allowed to use only one single bit. So what is that bit? That is 1. Now this is number 1. So what is our question? Whatever number is generated. So here we are having one number, that is string is represented by taking one bit. So what kind of this string is represented? This is number 1. If this is a number 1, what is our question is, You have to decide whether your numbers are divisible by 2 or not. And this thing we have already solved by using maths method. So if you are having number 1, whether the number is divided by 2. No, the number is not divided by 2. It is not completely divisible by 2. It is having the remainder 1. So what we are going to write that this is what is this kind of state is it is having remainder 1. So this state is what remainder 1 state. Let us give some name to this condition which is remainder 1. Let us call this state as Q1. Okay, and in this state what we are going to write here on the top of your tape, we are going to write the output symbols that are generated because of the operation, and here we are going to write the resultant state. Okay, so we are going to write resultant state here. So what is the state? In this state here, we are going to write the current state. What is our current state? And after reading any symbol here, what kind of output is generated because of this input, and what will be the resultant state. So here in this case, when we have considered bit 1, what is the situation is this bit 1 is representing remainder 1. What was the output that was generated here after taking the number 1? The output that was generated was number 1. In the case of number 2, what was the output generated? The output was generated is 0. In the case of 3, the output was 1. In the case of 4, the output was 0. In the case of 5, the output was 1. In the case of 6, output was 0. So the output is either 0 or 1. Okay. Now here the remainder 0. This is the state which has generated output 1. So what I can write here, I will write output 1. And to this state, which is our resultant state, our current state was QS. QS after reading 1 has generated the output 1, and it is going to the next state, which is your remainder 1. That means after dividing number 1 by 2, what we are having, we are getting output 1. To this output 1, we are giving a good name which is called as remainder 1. Remainder 1 in case of your mathematical method. Now in the case of TCS method, this good name which is remainder 1 is also called or known by one more name which is called as Q1. So what is Q1? Which string is represented by Q1? This string is represented by Q1. So what is the string? The string which is represented by Q1 is 1. Okay. So which string is represented by Q1 is 1. And what kind of output is generated? Here the output is present. The output generated is 1. Okay. Now we will go. And what here we got a new state. So as we got the new state, what we are going to do? We are going to consider that state. So this is the Q1 state, that is the resultant state. So whatever resultant state we are getting here, that we will consider as the current state. Okay. So what is our current state is now Q1. Which state, which number, which string is represented by Q1? Q1 here represent 1. So that I'm going to write here. Now this is already read string. Now here we are having next cell. After reading this bit, your pointer is now shifted here. Previously our pointer was here. After reading this bit, now the pointer is now shifted to the next cell. The next cell is empty. Now as we have used the unary number system, only one bit is allowed to be read. So what we are going to do? We are going to read the next bit. Now, after reading the next bit, your entire number, see, your entire number that is generated here is now number 2, 1, 1. So, 1 after that, one more 1 is added, is making number 2. So, what is the possibility of the number 2 in the mathematical method? In the mathematical method, when the number 2 is divided 2, the output was 0. So this output we are going to write here. So what is the output? Output was 0. Now, so what we are going to do? This output 0 is also known in mathematical method as a remainder 0. So what we are going to write here, we are going to write the situation as remainder 0. To this remainder 0, we are giving one name Q0. That means this situation when we are having number 2, output is generated as 0, the resultant state is now Q0. Okay, so which string is represented by Q0 is now this entire string is represented by Q0, which is 1, 1. Okay. So, what is the output of Q0 is 0. So that we are going to write here. Now this Q0, which was the resultant state, and this is according to our question. What was our question is whether the number is divisible by 2. And this state Q0 represent a remainder 0. That means this number, your number 2 is completely divisible by 2, and this is what we required in our question. So this is our solution. So this will be marked as the final state. So as this is the final state, and this was the current state. So what is our algorithm? We have to repeat the algorithm. So this current state will be this resultant state will become now for the next processing will become the current state. So this was the previously resultant state whose current state was Q1, and now this resultant state will become the current state. So this is your next step. So what this will be considered. So in the tape, we will mark the string which is represented by Q0. What is the string? What was the string that was represented by Q0 was 1, 1. So I will write this 1, 1 together because this is a complete string. Okay, so now we have already read this thing string 2 already read previously in Q0, and now the pointer is going to shift to the next position. So we have shifted our pointer here. The pointer is waiting here for the next bit. What will be our next bit? As we are using unary number system, that means it will be number 1. So this number 1 will be added here at the end of your previous bit. So previous bit was your string 2. When 1 is added to previous bit 2, it will become number 3. What was the scenario with the number 3? So when we are going to add when we are going to add one more digit after number 2, which number is generated? The number generated is 3 occurrence of number 1, which is decimal number 3. So what we have considered in decimal number in your number 3. When number 3 occurrence of ones are divided by 2, it's generating the remainder 1. So what we are going to write? We are going to write remainder here, which is your remainder 1. And what is the situation? Remainder 1, here we are going to write that we are having the state, the condition as remainder 1. Whether we had already considered this condition, remainder 1. Yes, remainder 1 is already considered here with the name Q1. So what we are going to write? We are going to write the resultant state as Q1. Okay, so here no need of writing Q1 again, which is generating the string 111 and generating the result as 1, because this state is already considered previously. So whenever we are having any state which is generated previously, which is repeating that state again and again, that will be the end point of your solution. Now what we are going to do, we have tried to try to find out the state. Now the second step in your TCS method is to write the state transition table. So here we are going to write state transition table. So what is there in state transition table? Here we are having one rows and column method. Here we are going to write the inputs. What kind of input we have considered? We have considered the input bit 1. Here on this side, we are going to write state. So what are the state that we have considered? So we have started with the state QS. Here also, we have started with QS. So I will take that state QS first. So this is your QS. So the QS with the input 1, QS with the input QS with the input 1, what is generating? It is generating result 1, and where it is going, the QS with the input 1 goes to the resultant state Q1. So QS with the input 1, where it is going to Q1. Okay, now the resultant state is Q1. So in this diagram, in this table, now we are going to consider next state is Q1 itself. So we'll write Q1. Now we will consider Q1. Where is Q1? Q1 is here. Q1 with the next bit is 1. Where it is going? It is generating to, it is moving to Q0. So Q1 with the next bit S1 that is going, it is going to Q0. Now this is the resultant state. Now we'll consider this one. This is Q0 and this is the final state. I will mark this by star. So Q0 now, Q0 with the next bit S1 that is going, it is going to Q1 state. So I am going to mark here. This is going to Q1 state. Okay, so this is all about the state transition diagram. The next step is we are going to, the next step in your TCS is your state transition diagram. So here I'm going to draw state transition diagram. Okay, in state transition diagram, the first thing is that I'm going to write the first state. The first state is the starting state. So I will mark within the circle. First, we have to draw a circle. Within the circle, we are going to write the state name. Now, as this is the initial state, so this has to be different from all the states. The starting state or the beginning state is always indicated by a small pointer, a small arrow that this is the initial state. So this is your initial state, I can see. Okay, now from QS on that is going, it is going to Q1. So I will draw one line, one arrow connecting. So here I will draw one circle. Within the circle, what I'm going to write? I'm going to write the resultant state, which is reachable from QS with the input 1. So this is the resultant state, which is whose name is Q1, and the QS and Q1 are connected with the help of 1. So QS on 1 goes to Q1. So I will draw a line, an arrow connecting the states. So QS on 1 goes to Q1. We have to draw an arrow in such a way that both the ends are touching the circles. Here the starting point also and this arrow mark also should touch the circles. Now from Q1 where it is going, Q1 on 1 where it is going to Q0. So the resultant state is Q0. So we'll first draw that thing. So this is your circle, and within the circle we'll write the state name, that is Q0. Plus this Q0, we already know that Q0 is the final state. So I will double circle it. So initial state is given some preference, that some importance. How the importance is shown is by putting this arrow. Another thing is that final state is also given some importance. What kind of importance is that? It is given double circle. Okay, now Q1 on 1 goes to Q0. So we'll connect an arrow from Q1 to Q0, and I will mark the, we have to write the input symbol over it. Now Q0 on 1, where it is going back to Q1. So I will draw a loop from Q0 to Q1, and we have to write input symbol here. Now this is the end of your state transition diagram, because we have considered all the state QS, Q1, Q0 in your state transition diagram. Now the fourth thing that we have to do in TCS method is we have to cross-check our finite automata machine. So that is your checking, how we are going to cross check. Okay, so how we are going to cross check is that uh, we will take one input that we have not previously considered. So let us take one input, that is one string. Number four, that we have not considered while designing our machine by using the TCS method. So what is, first you have to tell us, first you have to tell yourself whether the string is acceptable or rejected according to your question. What is our question is that your number should be divisible by 2. Whether this number 4 occurrence of ones is divisible by 4. This is nothing but decimal number 4. Whether the decimal number 4 is we had already considered is divisible by 2 or not. Yes, it is divisible by 2. So what we are going to do? We are going to write yes, this is the accepted string. Okay, so this is your accepted string. That means if this is the accepted string, it should end with your final state. So which is your final state here? Your final state is Q0. That is after processing this this string, we should end up with final state Q0. So how will cross again? So we will start, as always, we have started here with the starting state, which is QS. Here also we start with QS. Okay, and now we will read your table and find out the QS on 1, where it is going. So QS on 1. So QS on this one, where it is going to Q1. Now, what is remaining? What is remaining string after reading the first bit, the remaining string is 111. So what we are going to do now, we are going to consider the remaining string with the resultant state. The resultant state is Q1. Now I will consider this Q1 with the next bit. So next bit is 1. So Q1 on 1, where it is going? So Q1 on 1, it is going to Q0. So I will write Q0 here. So this is Q0. And what is the remaining string? The remaining string is 1, 1. Okay, now the resultant state is Q0. So what we are going to consider? We will consider only one bit here. So we'll consider Q0 on 1, where it is going. So Q0 on 1, it is going. Q0 on 1, it is going to Q1. So what we are going to write? We are going to write Q1. What is remaining here is 1, that we are going to write here. Now what is remaining? Q1 on 1. Where it is going? Q1 on 1 is going to Q0. So I will write the resultant state as Q0. So as we have ended with the, here there is not a single symbol is remaining after considering Q1 on 1, which is going to give us the resultant state as Q0. That means this is the final answer. So here we can reach your question whether the number 4 is divisible by 2 or not, is we are ended with the final state, which is 20, and we had already assumed that if we are reaching final state, that means your string is acceptable by your the string is accepted by your the string is perfectly divisible by 2, and your machine that you have generated, which is nothing but the finite automata, you have designed correctly. And if you want, you can take one more example. For example, I want to check whether the number 5 that we have not considered while designing, okay, by using the tape method, whether this is divisible, completely divisible by whether your machine is perfectly designed. We are going to consider a new string. So what is this number? Number 5 is, whether it is divisible? No, it is not divisible, leaving the remainder 1. Remainder 1 is indicated by the state Q1. So what is Q1? The Q1 is non-final state. Whenever we are reaching your output as a non-final state, that means this string is rejected by your finite automata. That means this is not the string which is divisible by 2. That means we shall not end your answer with the final state. We should end your state with any non-final state. So whenever we are going to end your string with any non-final state, That means your string is rejected by your finite automata. So let us start. We are started. We have to start with QS. Now QS with 1, where we are going? So with QS with 1, we are reaching to Q1. So what we are going to do? We are going to write Q1. Now this is already done and this is the resultant state. The remaining strings are 1, 1, 1, 1. Now next Q1 on 1. Q1 on 1, where it is going? Q1 on 1 reaches to Q0. What is the remaining string is 1, 1, 1. Now Q0 on 1, where it is going? It is going to Q1. What is the remaining string is 1, 1. Now next one is Q1 on 1 goes to Q0. Now what is remaining one? Remaining one is 1. So now Q0 on 1, where is going? It is going to Q1, which is a non-final state. So whenever we are ended with the non-final state, that means your string is rejected by your finite automata. So this is how we have designed finite automata for unary number system divisible by 2.